Welcome back, aliens. My name is Davin Reddy, and in this video we'll see the implementation of linked list. In the earlier videos we have talked about why do we need linked list and what is linked list. So let's try to implement that with the help of Java language. Again, you can implement that concept with any language which you love. In this video we'll focus on Java. We have two sections on this screen. We have on the left hand side we have Eclipse IDE. Again, you can use any IDE which you prefer. You can use IntelliJ, you can use NetBeans. I will be using Eclipse here. On the right hand side I have a paint, so that if I want to show you anything, any diagrammatical representation of that, whatever we are doing, you can see on the right hand side. So what exactly we need? So just to make a quick recap, what we have learned till now is when you talk about linked list, we have representation like this. We have node. Now these are our nodes, right? So let's create a first node here. So this is our first node, and let's say I want to store values like 5, 12, 6, 9. I don't know why I love these numbers. And let's say we have 8. So I want to store these 5 values. That's it. Nothing fancy, just 5 values in a linked list. So in linked list, what we do is we create individual nodes. So all these things are called as nodes, right? So this is a node, and then we'll create another node. So this node will have a value which is 5. And then we'll be having another node here, which is, let's say, value 12, and this node will have some address. And we'll be having one more node here, let's say 6. So this is 6. We have one more node here, which is 9. Again, I'm doing it purposefully, creating the objects anywhere. And then let's say we have 8 here. So we have all these nodes here. So this node, which is of 5, will be linked with 12. We have to find a way to link these two nodes, and then we have to find a way to link these two nodes, and this node. And this node. This is what we are going to do. So once we can link this node, in future if you want to add some new elements, you can do that very easily. Every node will have two things: a value, so this is your value, and this is your address. Now this is an address of the next node. Now in C programming we can use pointers, but in Java what we do is we create a reference of the next object. Java is all about objects, right? So of course this node is also object. So this is the first object, so you can say this is the first object, this is the second object. So the first object will have a reference of the second object. The second object will have a reference of the third object. Now again, we don't number them, but then every object will have a reference of some other object. The last object here will have nothing, it will have null, right? So we don't have any other object after that. So we'll be having null. Maybe after some time we'll add one more node. The reference of that node will be assigned here. So let's try to implement this. So what are the things we need here? So let's see what are things we need in Java perspective. So of course we need to create objects, right? So before getting the object, we need to use a class. So the first class we need is a node class, because a node class will have two things. A node class will have a data, and a node class will have the next node. So data will be of type int. Again, you can have any data you want. You can have a string data, you can have any object, maybe alien object, maybe accounts object, maybe a laptop object, your wish. And then the next node will be of type node itself, because this will refer to the next node. A node class, so this is a class which has two things. We have a data and a node. Then what are the class we need? We need a linked list class, right? Because linked list class will have certain features, because when you talk about linked list, it has certain methods. Example, we are going to look at insert. So we look at insert. Now insert will add data at the end. So let's say if I specify data as 5, it will add that at the end of the list. What if you want to add in between? So you will say insert, and you will say insert at. I want to specify the position. Let's say I want to specify position 3, or the index the value 3, and the value is, let's say, 12. So I want to add 12 at the location 3. Maybe I want to add element at the end. So I will say insert, or maybe at the start. We already done with the end, right? So we'll say insert start. So I want to insert at start. So you can say I want to insert at the start, which is 18. So it will add at the start. So this will add at the end, this will add at in between, and this will at the start. You maybe want to delete the data as well. So you can also use a delete method, and in delete you have to specify the index. Let's specify the index as 2. So it will delete the element at index value 2. These are the options I want to perform in my class. And then to run this, of course, we need a class which has a main method. So we'll have a main method in which you will be doing all these operations. So you will be having main, and then a main will have all the execution. It will have a linked list object, and then using that linked list object we can perform all these operations. And then we also want a show method, right? So show method will display all the elements. So if you want to display all the elements, you can do that. So this is what you'll be doing here. So in total we need 3 classes here. So this is the first class we want to work with, this second class we want to work with, and the third class. So let's create these 3 classes in our Java code. So let's do that. So I will say right click and let me create a Java class here. I will say this class name as node because the first thing which we are going to do is node. Now this node will have two things as we have discussed. The first thing it will have is the index value. I guess the font is not visible. Let me just do that. So now I would say this node will have the first thing, which is the int data. And as I mentioned, you can use any data you want. You can go for int, float, double, alien type, data, any complex type if you want. And the next thing is the node itself. So the node object which is next. So this node is a reference. So this next is a reference for the next node. Quite simple, right? So we have public class node and we have just two things. Nothing fancy here. We got just two things. You can make it more efficient. You can make it this private variables and you can use getter setters. But then just to keep it simple, I'm doing this code. The next thing we need is a class which is called as LinkedList. But what if, okay, let's get a main class first. I will say the main class and the main class name will be runner. Again, you can have any name, doesn't matter. We have runner class which has a main method. Now what if, or maybe I don't want to create my own list. I want to use the inbuilt feature. So in fact, in collection API, you do have a linked list as a class. So you can say linked list, I will say list equal to new linked list. In fact, you can use the internal one as well. You can simply use this class and you can say list dot. We have an add method. So using add, you can specify which object you want to add. Maybe I want to add 5. So this is same as the thing which we are going to do. We are going to use insert. Yeah. And then we'll be having list dot add. You can specify the index value where you want to add. Let's say I want to add the index value at 4, and you can add the element as let's say 12. So the same thing which we are doing here, maybe index value 3, which we're talking about. And then you can also delete elements. So you can say list dot delete. Okay, we have remove. So we have remove, we can specify the index value. The method which I'm going to use is delete. And then do we have a show method? We don't have a show method here, but we have size. Okay, we are missing size there. We'll be doing that later. And okay, we don't have the show method here, but then we have iterator using which you can fetch all the values. In fact, you can print the entire list as it is. That will work. This is how you work with list. But then I don't want to use the internal implementation. I want to go for my own implementation. So of course we need a class. So I would say the class name is LinkedList itself. Again, don't get confused with the name which we are using and which is provided by Java. I'm going for the same name, but since they're in different package, we can have our own class names. Now this class need to have certain methods, right? Even before creating a method here, what I'm going to do is every list will have one thing, and that one thing is, okay, so how do you know that this is a first node? Now, if you remember, we use a concept of a head node. So the first node will be referred as head node. And where do we define it? So in the list itself, I can say I have a node which I will call as head node. So this will refer to the first node. Okay, that's it. So we got that node there. Let's implement the functions. First of all, this code is difficult to understand it in the first go. What I would say is watch the entire video and then try it by yourself. So maybe you'll be watching this video 2 to 3 times. So make sure that you also practice this. That's where you will get this concept. Okay, so let's start with the first method. So the first method we want to go for is insert. So let's do that. So I would say public void insert. That's the first method I want to go for. And this will accept an integer value. I would say integer data itself. So this is what I'm expecting from the user. Now this data I want to assign to a node. So whenever you call a insert, what we have to do is we have to first create a node. So what I will do is I will just clear this up. So let's use this area here on this side. So what we are going to do is every time you say insert, you will be creating a new node. So let's get a node here, and this node will have a value which is whatever value you are passing. So what we are going to do here is let's create a new node, and then the way you create a new node is by saying node, and let's name that node as node itself, and we'll say new node. This is how you create object, right? So we got a node there. The moment you say node equal to new node, this is what you will be getting in your memory. The next thing we have to mention is 2 values of it. So we'll say node.data, the data which is coming from the user. So whatever user is passing, let's say if a user pass 5, the node will get the value 5. Just to make it more realistic, what I will do is I will also create the object of list, the linked list here in the main. So I would say linked list, I would name this as list itself equal to new linked list. And in this linked list, I have only one method, right, which is insert. This insert will take a value. Let's say I'm passing 5. So this method will call 5. It will pass 5, and that 5 will be assigned to a node, which means this node here, it will be having a value which is 5. That's simple, right? And by default, the value of this one will be null. So we got our first node. But then it is possible that this is our first node, because what we are expecting is when you say insert, it will add the data at the end. So if you already have a list with you, it will simply add data at the end. But what if you don't have a data itself? I mean, you don't have a list itself. This is your first node. In that scenario, you have to check, because if this is your first node, then the head would be null, right? Because by default, the value for this head is null. So if it is your first object, this is the first object we are inserting, so head is null. So we'll verify if the head is equal to null. In this case, I would say the node itself is a head. So we'll say head equal to node. So the first node itself is a head. But what if that is not a scenario? What if this is not your first node? We already have some nodes there. In that case, you will go for the else part. So the first case we are checking is what if your head is null? So then when you say head is null, it means you don't have any nodes in the list. So whatever node you are adding is a first node. In that case, we got the node. By default, the next value is null. In fact, you can, if you want to make it more readable, you can assign that to null. Even if you don't do that, that's fine, because by default, the value for the object is null. But then this looks more readable, right? So you can do that. So if it is a first object, that's become your head. But what if this is not the first object? In that case, you will create a node and you will make it as head. Okay, now why I'm doing this? It's because let's imagine you already have a list. So let's say if you have multiple nodes here, we got 6, and in fact, let's go back to the original diagram. Now you can see if I'm adding a node in between or somewhere here. So let's say I'm adding a new node, which is let's say, okay, the value which I'm passing here is not, let's say, not 5. It is let's say 18. I'm passing 18 now. So we got a new node. And of course, this is not the first node which we are adding. So head is pointing to 5. So in this case, what it will do is it will assign the value here, which is 18, right? We got 18 value here, but then this is getting added at the end, right? But that means after 8. What we have to do is we have to first check which is the last element. How do I know which is the last element? And that's where you have to start with the first location. So from the first location, you will travel from first location to the last location. Now that is tricky, right? How do we travel? Is it that easy? No, it's not that easy, but just try to understand. So from the first one, we'll go to head first, and using head, we'll jump to the next node. So from the second node, you will jump to the third node. From the third node, you can jump to the fourth node, and then fifth node. And then, but how do we stop? Where do we stop? So we have to stop the moment you get null as the next value. Okay, now this looks simple. So to traverse, you have to use a node, right? A temporary node which will hold the data, and that is, let's say, n here. So we'll say while n dot next. Since we have to traverse between different nodes, so we'll use a while loop. So we will travel till you got a null value. The moment you get a null value, the while loop will stop. So how do we traverse? So what we are doing is we are saying n dot next equal to null. So we have a temporary node here. Let's imagine I'm doing that node. I'm creating that node here. This is a temporary node, and I will call this node as n. Now this node will first refer to the head node. So it will refer to the head node, and then head node will check. Do we have a null value here? No, we don't have a null value. We have the address of the second node. In this case, a reference of second node. So it is not null. Okay, so then we have to jump from here to here. Now how do we jump? So to jump, what we will do is we will change. Earlier this was referring to this node, right? Now we have to refer to this node. Now how will you get this node? It's very easy. You will say n is equal to n dot next. So now you're jumping between nodes. So if it is not null, let's jump to second node. If this is not null, let's jump to third node. And using while loop, you can do that. Now this will stop the moment you get null at the end. Now once you got the null, what you will do is once you got this null here, you have to change this value. You have to change from null here. So this is not null anymore. So this will refer to the new node which you have created. Now how will you do that? So to do that, we have to say n dot next is equal to the new node which you have created. That means the value of this node, because the current n value is referring to this node, right? Again, this is the tricky part in Java. You have to work with objects. So imagine when the loop gets over. So at this location, when the loop gets over, you are here at this node. Yeah, you are here at this node. Now what you do is you have to just change this null to the next node, whichever you have. So this is a new node, right? So this is a node in our case. So the value of node will be assigned to the current node dot next, which is this value. So this will be replaced by the node reference. So you don't have a null anymore. And this is null by default. Now if you can see the code here, we have a null value here, right? Okay, this looks cool. Now this is how you insert value. Can we verify? Now even if you can verify, we don't have a way to print all the values, right? So I will insert the data, and I will also try to print it. Now how do we print it? We can use a show method to print all the values. So I will say public void show to print all the values. And how do I print the values? So we will use some methods we will use some statements to print here. Now how do we print the values? So same steps. You have to traverse from between all these nodes. Now how will you travel between all these nodes? Is you have to say node n. Again, you can say node equal to head. So initially you have to start with head, and then we'll be using a while loop. We have to travel, right? So when you want to travel, you will use a while loop. So you will say n dot node dot next is not equal to null. This is how you travel. And then, so while traveling, you will print the data of the node. So you will say system.out.println, and you will print the data of the node. So you will say node.data. That's it. This is what you are going to do. And every time you print it, you just have to shift to the next node. And the way you can shift to the next node is by saying node equal to node.next. This is how you shift. Now see this loop, the same loop. So same while loop, the only thing which you're doing here is we are printing it. That's it. Okay, I hope this will work, but let's try. So what I will do is I will insert not one value, I will insert 3 to 4 values. So I will say list dot insert, and I will insert 45 as well. And I will say list dot insert, I would say 12. Okay, let's add 3 values, and at the end I will say list dot show. I hope this will work now. So let's run this code. Right click and say run as Java application. And we got the output, but with one mistake. You are getting 18 and 45. That's perfect. We are not getting 12. So what's wrong? Is it not getting added, or is it not getting printed? I think it's not getting printed. It's because you are traversing till null, right? The moment you get null, you are stopping it. In this case, we only have 3 nodes. So in this case, we only have 3 nodes. Let me just draw that here. So we got the first node as 18, the second node as 45, and the third node as 12. So you got these 3 nodes, right? So this node is referring to this node. That means this is not null value. So this is not null. Even this is not null. But this is referring to this object, right? So this is null. So this here is null. So it will stop as soon as you get null. Oh, okay, that's weird. That means we are not printing this one. But we are reaching to this point, right? So when you say it will print data, it will not print data which has an object which is null. In that case, let's do it manually. So I would say system.out.println, and here I will say node.data. So for the last element, you have to print it outside the loop, because it will not getting printed in the loop itself. Now let's run the loop, run the code, and you can see we got those 3 beautiful values. So just to make a quick recap, what we have done, we have created 2 methods here. One is insert and one is show. In insert, what we are doing is we are creating a node, because that's what we do. Every time you say insert, it will create a new node, and that node will have a value which is, so whatever data you are passing will be assigned to that node. Now, if you want me to go for a quick run through of this, we can use a debugger. So what we will do is we'll use a debugger here, and let's apply a breakpoint. This is where I want to apply a break. And then I will run this in debug mode. I will say run as, okay, where's the debug mode? It's here. And let's jump to the locations. So we'll say F5, and F5 will take to the next thing. So what we are doing is, the moment you got a linked list, so I will just draw it here. So the moment you got a linked list, it will create the first element. So when you say insert, so insert, what it is doing is, it is saying, it will create a new node for you. So here it will create a new node. Okay, we got the node there. And then we are saying, okay, it will go to node class, it will take those 2 values, and then it will assign the data. So data is 18. Can you see that? It's 18, and we got 18. Yeah, and the ID for this is 22. So let me just write 22 somewhere. So we got 22. So the value is 18 and the value ID is 22. And then it is saying null. So the next one is null here. And then it is saying if it is null, is the head element null? Yes, by default is null. So head is null here. right? Head is by default null. In this case, this becomes your head. So head will point to this location now, and then it will not go to else part because if got executed. It will jump back to the second value, which is 45. So in this case, it will try to insert 45. So the same step, it will create a node for you. If I jump into this, you can see it is creating a new node, and with those two beautiful values, which is data and next, it is assigned data, which is 45. So we got 45 here, and then the next value is, so this is null. Now, when you say null, it will jump to the next location. Is it head null? No, head is not null, right? Because head is pointing to the first node here. So if will not get executed, it will execute the else part, and that's working. Now it will traverse between the elements, right? So first it will jump to head and check if, so it will traverse. The first element itself is null. So it will directly jump to the location here, and it will say the this dot next. So this value will be replaced by the reference of the next element, which is 20. Okay, what is the ID for this? The ID for this node is 23. So this will refer 23 now, and then it will jump back to the insert the third block, and we got the object here with the value 12. The same steps will happen. Now it will again go back, it will create the object, assign the data 12, and then this will be null. So the text will be null here, and then it will jump to next. It will jump to head. Is it so head is null? No, head is pointing to the 18th location, so it will not execute the if block. It will execute the else block. In else block, it will traverse from the head block to the end block. So is the first block is null? You can say no, it's not null. So it will execute. It will say jump to the next location. So now n is referring here. Now is it null? Yes, it is null. You can see that it is null. So the moment you get null, it will execute. It will say the n dot next. Next is this one. So this will be replaced by the ID 24. So the ID for this object is 24. This will be 24 here, and then you got a link. It's that simple. The end of the code, and then when the moment you say show, what we are doing in show is we are jumping from one location to another location. So it will start with the head location, and it will check, is it null? No, it's not null. So let's print the value. So it will print the value of it, which is 18. So we got 18 there. You can see the output console window here. We got 18, and then when you say next, you can see it is printing the next node now. So it is referring to the node 23. Is it? Yeah. So now 23, and then it will print the value data of that, which is 45. And now so the moment I go back, you can see the node ID is 24 now. It is referring to 24, and it will print the data, which is 12. So this is the beauty of linked list. Now you can add values anywhere. Again, this is a lengthy video, so what I will do is the remaining part we'll see in the next video, where we'll talk about the other methods which we have discussed. We'll talk about insert, at start, delete, and show. So the next one will be faster because we have seen the difficult part. So I hope you understood something about linked list. Again, you may want to rewatch this video again. So let me know in the comment section if it was helpful. And thank you so much for watching, everyone.